right, good afternoon, 8th period and possibly 7th period. Um, you should have completed just the parent function for the 8.3 worksheet, and now I want to help you investigate what the transformations do. So y equals 1 over x is just like the parent function, right? So some points that we see are the 1, 1, and negative 1, negative 1. Okay. Here we go. So if you had something like 1 over x and then plus some value outside of the function, ask yourself, what do you think that this is going to do? Okay. Were you right? So adding a value outside of the function will just shift your graph up or down. Notice the horizontal asymptote is being shifted. So originally it was the x-axis, now it's y equals negative 3.7 is where that asymptote is. Okay. Let's talk about if you were adding inside the function. It would go in the denominator with x. That's the one that's going to move your graph left or right. And so we really have kind of two different things at play here. Let's make a 3, 2. Okay. Where the asymptotes will fall would be x equals negative 3, and that's because you've shifted your graph left 2 units. And then there would also be a y equals 2, and that's because you've shifted your graph up 2 units. So this point of negative 3 comma 2 is almost, I hate to call it a vertex, but it's sort of like a vertex, because from that intersection of your two asymptotes, you go right one, up one, and you'll have a point on your graph, and left one, down one, and you'll have another point on your graph. There it is. So as long as you know what direction the graph moved, left, right, up, or down, you can draw in your asymptotes first, and then draw in the curve on either side. Okay. Now let's talk about reflections. Ask yourself, in what way do you think you can reflect this graph? Some of you might think you can put the negative out in front, right? Well, that's true. You can also put the negative down below. So what that means is, with rational functions, a horizontal reflection going left to right is the same thing as a vertical reflection going top to bottom. Okay, so it doesn't really matter where you put the negative. Okay, you could even put it in the numerator if you want, and it still does that same thing. Okay, so the idea is you still have to translate first, move left, right, up, or down, but then if it's negative, it kind of tells you what quadrant to graph in. And then lastly, let's do a dilation. So if you had some number multiplying out in front, a times, okay, it's going to pull your graph kind of further away from that intersection of your asymptotes. And then if a is negative, obviously it'll do that reflection. So I'm just going to pick out like 5, for example. This is equivalent to 5 over x, same thing. So you can see that stretch factor in front, or you can see it in the numerator. But we used to be able to say with the parent function, it's just from the intersection of the asymptotes, you go right one, up one, and you have a point. Well, that's not true anymore, and it feels kind of arbitrary, this random thing. So what's happening is this point gets split, and it's stretched both horizontally and vertically, as crazy as it sounds. So one point that we know it's now going to be at is 5 comma 1. And that's because, let's label that one too. Horizontally, we were only like right 1, up 1. Now we're going to go right 5, up 1. And that's because of the stretch factor of 5. There's also the point of 1 comma 5. So it's stretched vertically as well. You usually went right 1, up 1. Now we're going to go right 1, up 5. So we have that your, almost kind of like your vertex on each side gets stretched, or it's pulled in both horizontal and vertical directions. So it's not just in one direction, guys, it's going to be in both. So these are unique in that all you have to say is reflection, because it'll happen in both directions. And you just have to say dilation, because the dilation will happen in both directions as well. Okay, go ahead and do the 2 examples on the last part of your worksheet, and then use Desmos to double check your work. Thank you.